we're going to be discussing transformational geometry. Now, there are four main transformations that we will look at. These are translation, which means that you have an object that slides. It may slide horizontally and vertically in one direction, then the other. It may slide to the right, then up, slide to the right, and then down, whatever the case is. So you have the object here, and it slides to the right and then up to a new location. It might slide to the right and then down to a new location. It might slide to the left and up, or it might slide to the left and down. Alright? Reflection means if you have a reflection over the x-axis, whatever is here, it's reflected over here, so that you have an equal distance to the y-axis. If it is reflected over the y-axis, you can have a reflection over the x-axis, an object 2 units above ends up 2 units below, or 2 units below ends up 2 units above. Reflection over the x-axis means x is a mirror line. Reflection over the y-axis means y is a mirror line. You could also have reflections over other lines, which we will look at later. There's rotation, where you rotate an object around a point at a certain angle. And then there's enlargement, where you have a center of enlargement, which is a certain point, and a factor, a scale factor. 2 means each side of the object is 2 times as long, or each side of the image is 2 times as long, because the image is the new object, or the new what you have originally is called the object, and then the result is called the image. Alright? So you might have, say, this triangle, and then it's translated and it ends up here. You have no change in orientation. That means whatever part is straight up is still straight up. Whatever part is slanted at 30 degrees to the horizontal is still 30 degrees to the horizontal. The sizes are the same. Alright? Same shape, same size. It's just that you slide it from here to here. You might have a reflection, say, over the y-axis. So the y-axis becomes a mirror image. Alright? So it looks like a reflection over that line. Alright? Now, you may have a rotation, where, for example, this is the center of rotation. If you have lines going to each vertex of the object, this is the original object, and you rotate it a certain angle over around this point, which is the center of rotation, each point on the object is rotated through that same angle, right? And then you have the image, which is the reflection of the object. It will have the same size, same shape, it's just that you have it rotated, and the center of rotation would be right here, right? The center of rotation. This angle is the angle of rotation. Then there's the enlargement. suppose I erase some of what I wrote here, and this point is the center of enlargement and the scale factor is 2. It means you would extend these lines. They may be broken lines, they may be solid lines that are of a different color or thickness, just for construction purposes. And if the scale factor is 2, it means the distance from here, from the center to the vertex here, right? When you compare the distance to the vertex on the image, it's twice that of the object, from the object to the center of enlargement. So you have a larger triangle. All right, same shape, it's just that you have a different size. I'm trying to fix up this triangle to make it kind of look like the old one. You may even have what is really a reduction if you have the scale factor less than 1. For example, half, you will end up with a smaller triangle. All right, so we're going to be looking at these in additional videos as we examine transformational geometry.